Hello everyone, this lab is about OSPF for IPv6. I have created a simple topology and I will quickly configure it assuming that you have the basic understanding of IPv6. Firstly, I will get started with configuring interfaces for IPv6 addresses. I will configure this lab with simple IPv6 addresses such as 2001 colon AB colon slash 64, which is the default mask, and this lab is based on single segment or a single broadcast domain, which means there is one switch in between the routers and they are sharing one network address. This is also known as shared segment. As you can see, we are receiving messages for duplex mismatches from the switch, so we can do some changes in duplex settings to stop these messages for the purpose of this lab. I will be giving an IPv6 address of 2001 colon AB colon. So for my easiness I am using the naming convention. Suppose for R1 I will be using colon 1, for R2 I will be using colon 2, for R3 I will be using colon 3. As you can see, this topology is connected with the switch, so they will be sharing all the same network, only the host part will be different. So currently the switch interfaces are running in full duplex. Let us change for all the interfaces connected to the routers to half duplex. So for the purpose of the lab, these messages will stop. Let us ping EV. I am able to ping the local segment. Show IPv6 router OSPF. I will use the process ID of 1. IPv6 is not enabled, so the command is IPv6 unicast routing. So I will copy paste it on all the routers to enable IPv6. So on R3 IPv6 unicast routing, on R2 also. Now I will go ahead and configure IPv6 OSPF. So router ID is must. It is giving error could not pick a router ID because IPv4 addresses are not currently configured, and if we had IPv4 addresses, OSPF process would select the highest physical IPv4 address. So in our case we will manually configure the router ID. So area 0 I will take for the purpose of lab. It's a small scenario. So now to IPv6 router OSPF process ID of 100, then the router ID. So I will give for R1 as 1.1.1.1, for R2 as 2.2.2.2, for R3 as 3.3.3.3. IPv6 router OSPF 100, router ID quadruple 3. I will enable it on the interface level. So you can see this interface is participating in IPv6 process. The process ID is 100, area is 0. So neighbors, you can see I have router 2 and router 3, and state is currently in progress. So normally in a shared segment, when you have switch, so it takes times for selecting the designated router and backup designated router. So you can see we have received the messages after a while. We can see only the local routes and the connected routes. IPv6 OSPF neighbor. Now we can see R3 is the designated router and R2 is the backup designated router. So currently priority is not set, so that's why R3 is considered as designated router. So what we will do for the testing purpose, we will create loopback interfaces and we will advertise it in the OSPF process. On R2 we will take we will take the same. We'll check we will change the host part. Now we will check show IPv6 route OSPF. The thing is we have to advertise the loopbacks in IPv6 OSPF process. Show IPv6 route. Still we cannot see because the loopbacks are not yet advertised in the OSPF process. So in a while we will just go and advertise the loopbacks. I'm just pinging. So on R2 loopback 0, IPv6 OSPF 100 area 0, configure terminal interface loopback 0, IPv6 OSPF 100 area 0, and now we can check on router 1. It will be definitely showing now. So we can see the routes with the code O for OSPF process. Now if we ping, it will be reachable. So we are able to ping without any packet loss. So I hope this video was informative to you, and I would like to thank you.